This is the second part of the lecture on writing equation of motion in a rotatory non-inertial frame. Actually, in the first part of this lecture, we have started to know about the Coriolis force and the centrifugal force, which are actually the pseudo forces or fictitious forces, while writing equation of motion of a particle with respect to a rotatory non-inertial frame. So this lecture will be started by knowing what we have learnt in the previous lecture. Actually, we have seen that there is a particle of mass m moving in space, and we have considered two frames of references. The first one was actually a frame S, which was a fixed inertial frame, and the second was a frame S prime, which was actually a rotating non-inertial frame. And this is the particle P, which is in motion in a space. The observers of these two frames of reference actually observe the motion of the particle, and we have learnt what is the acceleration of the particle in the rotatory non-inertial frame. Actually, we have related the acceleration of the particle in rotatory in non-inertial frame with the acceleration of the particle in fixed inertial frame. And you have seen that the acceleration of the particle with respect to the rotating non-inertial frame, which we have denoted by the symbol A prime, that was equal to A minus 2 omega cross V prime minus omega cross r minus d omega by dt cross r. This was the relation which we have already derived in the first part of this lecture. Actually, you have learnt that in this expression, A represents the acceleration of the particle in inertial frame S, and this A prime, this is just the acceleration of the same particle A with respect to the rotatory frame S prime, which is a non-inertial frame. And omega here is actually the angular velocity of the rotatory frame S prime. And this V prime, this is actually the velocity of the particle observed by the observer of frame S prime. It means you can say that this is velocity of the particle with respect to the rotatory non-inertial frame. And R, you have seen in the figure, this is actually the position vector of the particle with respect to the origin of both of the reference frames S and S prime. Actually, R has same value with respect to both frames S and S prime. Okay. Now, if you consider that our rotatory frame is rotating with a constant angular velocity, it means omega is constant. Then if omega is constant, certainly this d omega by dt will be equal to 0. And if d omega by dt will be 0, this last term in this expression A will vanish. That will be 0. Actually, now the further discussion is based on this idea that we are considering a rotating frame which rotates with constant angular velocity. So in our further calculation, this term will not exist because we are considering d omega by dt equal to 0 since omega is constant. Okay. Because most of the problem which we will see in the forthcoming lecture, that will be for a reference frame which rotates with constant angular velocity. For example, we will consider the motion of a particle in Earth's rotating frame, and the frame of Earth is a rotating frame, but it rotates with constant angular velocity. Okay. So when you consider that our frame is rotating with constant angular velocity, then this A prime will be what? That will be simply A minus 2 omega cross V prime minus omega cross R. Okay, so I have mentioned it here. You can see this A prime is now equal to A minus 2 omega cross V prime minus omega cross R. Actually, till this equation we have learnt in the previous lecture. Now our aim is to write down the equation of motion of the particle in the rotatory non-inertial frame. So how we will write this equation? There is a simple, this is just a simple concept. If you know the acceleration, you can easily apply the Newton's second law of motion. And for this, let us multiply this equation B both sides by mass m of the particle. So when we will multiply this equation B with m, which is mass of the particle, what will be your result? You can easily see. Actually, I have written the RHS of this equation in LHS here. So you can see this will be ma minus 2m times omega cross V prime minus m omega cross R, and that's equal to ma prime. Okay, and this expression may be written like this. This is f plus f naught equal to ma prime. F plus f naught equal to ma prime. Okay, actually here this f has been written instead of this ma. And what is this ma? You can see m is mass of the particle and a is acceleration of the particle with respect to the inertial frame. And you know from Newton's second law of motion, the product of mass and acceleration of the particle with respect to an inertial frame gives the resultant of the total real forces, all the real forces acting on the particle. So this F, which is equal to ma, this represents the resultant of the all real forces acting on our particle. Okay, and this F naught has been written for the remaining two terms in the LHS of the above equation. So you can say that this F naught is equal to what? This is minus has been taken as a common factor, minus 2m times omega cross V prime plus m omega cross R. Okay, actually the sum of these two terms actually give the pseudo force or the fictitious force acting on our particle in the rotatory non-inertial frame. So in this case you can see there are two pseudo forces or two fictitious forces. Okay, and so this equation which I have written here in equation number 1, this equation actually reads as real forces, this is for ma, plus fictitious forces which represents this F naught, that is equal to ma prime. But you know m is mass of the particle and a prime is what? This is acceleration of the particle in rotatory frame S prime. And actually this you have learnt already in the previous lecture, that whenever we have to write down the equation of motion of a particle in a non-inertial frame, how we write it? We write the equation in this manner. You have to add a fictitious force or a pseudo force in the real force, and then you have to equate that net force equal to mass of the particle into acceleration of the particle in non-inertial frame. So this is a common fact for writing equation of motion in a non-inertial frame, which we have learnt in the second lecture on this in this lecture series. Actually here this minus 2m times omega cross V prime, which I have denoted by the symbol Fc, this is called Coriolis force. And as I have told you earlier that this word Coriolis has been used here in the honor of its inventor, Coriolis. Coriolis is actually the name of the mathematician which actually proposed this concept. And so this pseudo force or fictitious force, which is equal to minus 2m times omega cross v prime, this is called Coriolis force. And Coriolis force is not a real force, it is a fictitious force. Okay. And similarly, this F naught prime, not F naught have is actually sum of these two. This F naught prime is equal to minus m omega cross r. You have learnt in the previous lecture that this minus omega cross r is called centrifugal acceleration, and when you will multiply it by m, which is mass of the particle, this gives another fictitious force, and that second fictitious force is called centrifugal force. So in this case, whenever you will write the equation of motion of a particle moving in with respect to a rotatory non-inertial frame, definitely in your calculation there will be two pseudo forces. First one is called Coriolis force and the second one is called centrifugal force. And taking these two pseudo forces under account and adding them in the real forces, you can write the equation of motion of the particle with respect to the rotatory non-inertial frame. Okay, I think you are getting the things. Now, actually, to know the physical significances of these Coriolis force and centrifugal force, which are actually the pseudo forces, we will discuss these two pseudo forces separately. How we will write equation of motion, that has been already finished. You have to add the fictitious forces, which are Coriolis force and centrifugal force, in the real forces, and then you have to equate that total force equal to mass of the particle times acceleration of the particle with respect to the non-inertial frame. But now we will actually explain, or we will know some of the important facts regarding this Coriolis force and the centrifugal force. Okay. So first of all, you have to know about the Coriolis force. Let us see. As you have seen that this Coriolis force is nothing, this is simply a pseudo force or a fictitious force acting on the particle when the particle is in motion with respect to the rotatory inertial, non-inertial frame. It means this pseudo force will come into our calculation or will come in writing the equation of motion of the particle only when the particle is in motion with respect to the rotatory non-inertial frame. If the particle is at rest in rotatory non-inertial frame, then this force does not play any role, or this force does not appear in your calculation. When you have studied circular motion in your 11th level class, then you have seen you have never faced such a pseudo force, that is Coriolis force, in your calculation, because in 11th level we always talk about a particle which are stationary in rotatory frame. So in our calculation there was only one pseudo force, and that was centrifugal force. You have not talked about Coriolis force in your 11th level physics. Okay, but here we are considering the general situation that the particle under consideration is in motion even with respect to the rotatory frame. So when a particle moves with respect to rotatory non-inertial frame, then you must take into account a pseudo force acting on the particle, which is called Coriolis force. And this Coriolis force is defined by minus 2m times omega cross v prime. Mark it. You have to write its expression with minus sign here. Don't drop the minus sign. Okay. Now, if you consider that this theta is the angle between the vector omega and this v dashed, then from the definition of vector product of two vectors, what will be this omega cross v prime? This will be simply omega v prime sine theta into a unit vector, let us say n hat. As you can see that if we will swing omega into v prime, the swinging will be anti-clockwise in accordance with this figure. And so this cross product of omega and v prime will be perpendicular to the plane of this omega and v prime and onto the page in accordance with the right hand screw rule. Okay. But due to this minus sign, this Coriolis force will be just inward direction, perpendicular to the plane omega and v prime, if the place of omega and v prime are as shown in this figure. Okay. So now let us apply the formula for cross product of two vectors, and you can see that if theta is the angle between omega and v prime, then this fc will be what? This will be minus 2m omega v prime sine theta n hat. As I have told you that this n hat is a unit vector perpendicular to both omega and v prime in accordance with the RHSR. RHSR here stands for right hand screw rule. Okay. And if we will take the modulus of this pseudo force Fc, what will be that? That will be 2m omega v prime sine theta, because you know mod of minus n hat will be equal to 1. This is because a unit vector. Okay. So this is the magnitude of the Coriolis force. And you can see the magnitude of this Coriolis force actually depends on three factors. What is the value of omega? What is the value of v prime? And what are the directions and omega and v prime? That is, what is the angle between omega and v prime? So now let us see here. Since Fc has been defined by the vector product of two vectors omega and v prime, so in accordance with the definition of cross product of two vectors, you can say that this Fc will be perpendicular to omega and it is also perpendicular to v prime. This is just evident from the definition of cross product of two vectors. Okay. In other words, you can also say that the Coriolis force is perpendicular to the plane containing omega and v dashed. Okay. Now, you can see if we consider that v prime is 0, that is the particle under consideration is at rest in the rotatory frame, then what will happen? Since v dashed will be 0, then in accordance with this equation 4 or the basic equation 3, you can see that this Fc will be equal to 0. It means no Coriolis force acts on a particle which is stationary in a rotatory frame. If the particle is stationary at rest in a rotatory frame, then never say that a Coriolis force will act on it. A Coriolis force will not act on the particle. Okay? If the particle is at rest in a rotatory frame. But there are other two situations when the velocity v dashed, that is velocity of the particle with respect to the rotatory frame, will be not 0, but in spite of that the Coriolis force will be 0. And what will be those two situations? The first one is, if you consider that omega vector and the v dashed vector, if both of these two vectors are parallel to one another, then you know the angle between two parallel vectors is 0. So in this case theta will be 0, and you know sine theta will be then 0, because sine 0 is 0. And if sine theta is 0, you can see that no Coriolis force will act, Fc will be 0. And in a similar manner, if you consider that these two vectors omega and v prime are in opposite directions, that is anti-parallel, okay, then angle between them will be 180 degree, that is pi, and sine 180 degree is also 0. So in this case sine theta will be 0 too, and so FC will be 0. So you can say that if the two vectors omega and v prime are collinear, actually these two conditions may be stated in a single statement, that if omega and v prime are collinear, then no Coriolis force will act on the particle. When you say that omega and v prime are collinear, that means either omega and v prime are parallel or they are anti-parallel, because collinear vectors may be parallel or may be anti-parallel. Okay, so when omega and v prime are collinear, Coriolis force will be 0. So these are three situations when you can say that no Coriolis force will act on our particle. First one was what? First one was the particle is at rest in the rotatory frame. The second and third conditions can be stated as if omega and v prime are collinear, then no Coriolis force will act on the particle. Again, if you consider that if these two vectors omega and v prime are perpendicular to one another, it means the angle between them is pi by 2, then you know sine theta will be equal to 1, sine 90 is 1, and 1 is the maximum value of sine theta. So in this condition the magnitude of the Coriolis force will be maximum when omega and v prime are perpendicular to one another. And what will be that maximum value? That maximum value will be simply equal to 2m omega v prime, because this sine theta in equation 4 will be 1. So this is the maximum value of Coriolis force acting on the particle. So I think you have learned what is this Coriolis force. In nutshell, you can say Coriolis force is a fictitious force which acts on a particle only when the particle is in motion with respect to the rotatory frame. Okay, and this force is always perpendicular to the plane containing the angular velocity omega of the frame and the linear velocity of the particle with respect to the rotatory frame. And this force will be 0 when the particle is either at rest in a rotatory frame or omega and v prime vectors are collinear. Okay, and it is maximum when omega and v prime are perpendicular to one another. Okay, so I think now the concept of Coriolis force is very clear to you. Now you have seen the another fictitious force which we have to take into account acting on the particle while discussing its motion in a non-inertial rotatory frame is called centrifugal force. Is called centrifugal force. And how this centrifugal force is defined? Actually, when our particle is at rest in the rotatory frame, then you know Coriolis force will be 0. In that condition, the only one pseudo force acts on the particle, and that very pseudo force is called centrifugal force. So you can say that centrifugal force is not a real force. It is not a real interaction. It is just a fictitious force which comes into picture when our particle is stationary in the rotatory frame. Okay, and how it is defined? Its expression is f naught dash equal to minus m omega cross r. Okay, this is actually the expression for the centrifugal force. Now this idea of centrifugal force is used particularly in case of circular motion, which we have learnt in your lower classes. So I am here explaining this centrifugal force particularly in case of circular motion. So now let us consider there is a particle moving along a circle, as you can see in this figure. The motion of this particle can be described in two frames. The first frame you may consider fixed at the origin or at the center of the uh, circle, and that is an inertial frame. In that frame, no centrifugal force will act on the particle. Okay, no pseudo force. But if we consider that the rotating particle is itself a frame, it means you are considering the motion of the particle which moves along a circle in its own frame. In fact, in that condition, we must have to consider the pseudo force acting on it. And for convenience, I have considered that the particle which is moving along a circle, that circle lies in xy plane, as you can see in this figure. This is just an example to know the fact clearly, easily. Okay, and at any moment we consider that our particle is at this point P lying on the x-axis. Okay, and here if the particle will move in xy plane, then and you consider the particle itself a rotating frame, okay, then the angular velocity of this rotating frame will be perpendicular to the plane of this circle. And so as the circle lies in xy plane, you can say that omega will be along the z axis. So I have written here omega is equal to omega k, because k is the unit vector along the z axis. Okay, this is perpendicular to this plane. Now let us find the centrifugal force acting on this particle. Utilizing this expression, which is general expression for centrifugal force. Now in this particular case, what will be the expression for this centrifugal force? We will see. Okay, now let us see. The position vector of the particle with respect to this origin O, that is center of the circle, this is r, and this r will be equal to ri hat, because this r vector lies along the x-axis. Omega is along the z-axis in this example. Okay, so you can see F naught dashed, which represents the centrifugal force. The general definition, or the generalized definition you can say, is minus m omega cross r. But in our present example, we have considered that omega is along vector k, so omega has been written as omega k hat. And omega cross r, so this will be omega k cross ri, because we have considered that position vector r is along x-axis. Okay, now you know that k cross I, do you know what is this? K cross I, this is equal to j. K cross I equal to j. So this will be m omega square r times k cross j. But k cross j is equal to minus I, you know. So this F naught dashed will be minus m omega square r times minus I hat. So this minus minus will become plus, and F naught dashed, which represents the centrifugal force acting on a particle moving along a circle of radius r, is equal to m omega square r I hat. And you can see I is from O to P. I unit vector is along the positive x-axis. So this centrifugal force acts on our particle away from the center of the circle. So in case of circular motion, when you consider centrifugal force acting on the particle, you must take its direction away from the center, and so that its name is centrifugal. It means moving away from the center. Okay, so this is a particular example, but general definition you know of centrifugal force is this minus m omega cross r. Okay, so I think after this discussion, the concept of Coriolis force and the centrifugal force, which are actually pseudo forces acting on a particle moving in space when we discuss its motion with respect to a rotatory non-inertial frame is now completely clear to you. This is my keen faith. Okay, thank you very much.